Hello, welcome back. We're going to run this lesson and the last lesson in the sequence of simplifying these radical expressions that involve multiplication and division. But here we're going to finally kind of come to the end game of what we were really trying to accomplish. All of these expressions that we're going to be doing in this lesson and the next will involve variables. So we might have square root of 18x squared divided by square root of 3y squared or something. So we'll have variables mixed in with the numbers. We've done 3 lessons before this, and we've done tons of problems, but they've all involved numbers because I want you to get comfortable with what to do. Now that we introduce variables, it's going to be a piece of cake because it basically follows the same recipe, but there's a couple of things along the way that we have to be careful for. But the big picture is it's going to follow the same rules that we have used in the past. Now, before we do our first problem, I want to remind you of something right in the beginning because we'll be using it a lot throughout this lesson and in the next lesson. And that is the following thing. Let me switch colors here to purple, and I'm going to kind of leave it at the top and just kind of leave it up as we solve our problems. So in general, I want you to remember, well, let's just do it like this. We'll do it a couple of different ways. Okay, what if we have the square root of 7 squared? What does that equal to? Well, you know that 7 times 7 is 49, and so you take the square root of 49, you're going to get 7, right? So really what you have, if you really want to think about it, is a factor tree of 7 times 7, take a pair, and there you get a 7. And you can also think of it as this square root canceling the square, leaving a 7 behind. So that's all fine. But here's where the issue comes in. What if you have, under the radical, -7, and you square it, and you take the square root? A lot of students will just take the square root and cancel with the square and say that the answer is -7 because it makes sense the square root would cancel with the square and you're left with -7. But the problem is, although it does seem that that's the case, look what's going on. If you take -7 times itself, which is -7, you would get a positive 49. And you take the square root of that positive 49, you're still going to get a positive 7 back. So the bottom line is when you're taking a square root of something that is squared on the inside, right? You do go ahead and basically they cancel and you're left with what's in the middle, but really you have to take the absolute value of what's in the middle. Even if it looks like you're striking through and canceling everything, you're basically taking what's in the middle and you're taking the absolute value. So in general, the rule that I really want you to follow is if you're taking the square root of some variable x squared, where x can be anything, it can be positive, it can be negative, then really, yes, you're canceling and you're left with the variable x, but don't just leave it like this. Write an absolute value around it, because that tells you whatever you actually have for the value of x, strip away the sign and then just keep the positive version of it. And this comes about because when you're taking the square root of something that is squared, even if that something is negative that's squared, it still makes it positive. So you take the square root and it becomes positive again, right? So this is the general rule. When you take the square root of x squared, it needs to be absolute value of x. I'm going to do my best to remember to write that down, but even I forget that sometimes. So if you see me canceling something, I forget an absolute value, try to forgive me. But generally, this is the more mathematically correct way to write it. Because when x is positive, yeah, it just comes out. But when x is negative, really, it doesn't just come out, it's the absolute value. Now, along these same lines, let's go back to red over here. We'll go and kind of divide the line over here. We'll do something similar. What if you have, let's do 7 cubed. And instead of a square root, you're going to take a cube root. It's the same kind of thing. You can think of 7 as 7 cubed as 7 times 7 times 7. So you select a group of 3, and you end up with 7. So you can think of the cube root canceling the cube, leaving you with 7, which is left over. Now let's do the same exact thing. Let's make it -7. We're going to cube it on the inside, and then we're going to wrap a cube root around the whole thing. What's going to happen? Well, -7 times